Hello everyone, myself Nishant Kumar Karn and I am a second year undergrad student from National Institute of Technology, Agartala. Today, we are going to solve another very beautiful question from a very beautiful exam, JEE Advanced. So let's get started.
So in this question we are given that we have two blocks, a block of mass 2 kg and of mass capital M, both rest on an inclined plane and are separated by a distance of 6 meters. The coefficient of friction between these two blocks and the inclined plane is 0.25. The 2 kg block, that means this block, is given a velocity of 10 meter per second up the inclined plane. That means in this direction it is given a velocity of 10 meter per second. This block actually collides with this one, collides with this block of mass capital M, and then comes back at the same position from which it has started. That means this block first goes up, collides with this mass, and then comes back at the same position from where it started. And when it comes back, it has a velocity of 1 meter per second down the inclined plane. So we have to calculate the coefficient of restitution between the blocks and the mass of this block. That is the value of capital M and the coefficient of restitution between the block of mass 2 kg and the block of mass capital M. So before beginning the solution, let us take a few considerations. Let us assume V1 to be the velocity of mass 2 kg just before collision. Let V2 be the velocity of the mass 2 kg just after collision, and V3 be the velocity of mass M just after collision. Because the velocity of the mass capital M just before collision was 0, so we don't take that thing into account. Now let us make a few FBDs. The very first FBD, that is FBD1, will be of the mass 2 kg just before collision. So what happens is, this is the inclined plane. Here we have the block of mass 2 kg, which is moving with a velocity of 10 meters per second, and here just before collision it travels in this direction and reaches at this position while colliding with the mass m. Let v1 is the velocity just before collision. Now we have to apply the conservation of energy, that is the work energy theorem we have to apply here, which states that total change in kinetic energy will be equal to the work done by friction plus the work done by gravity. Now, the change in kinetic energy can be given as half into small m multiplied with the final velocity square minus the initial velocity square. Now the frictional force, that the work that will be done by the frictional force is obviously negative in sign. The magnitude of the frictional force will be mu mg cos theta, and with the force we have to multiply the distance, that is 6. Now the work done by gravitational force will be minus of m into g into h1. Now what is h1? H1 is the total upward displacement of this mass 2 kg. Here it is actually traveling a distance of 6 meters along the inclined plane. So the total vertical distance will be h1. Now this block actually, when it travels along the inclined plane, it travels some horizontal distance and some vertical distance. So we have to consider the vertical distance while considering the potential energy, the gravitational potential energy. So here we have h1, and it is in negative sign because the direction of the force and the direction of displacement due to the force both are in opposite direction. So the equation is simplified as minus mu mg cos theta into 6 plus minus of mg into 6 sin theta. Now we have to simplify this. Now in the question we are given sin theta equal to tan theta equal to 0.05, and g we have to consider 10 meter per second square. So basically we are given the value of theta, we are given the value of g, we are given the value of small m, we are given the value of mu. So we just have to solve this equation, and after solving this we get v1 equal to 8 meters per second. So here we have the velocity of the block of mass 2 kg just before collision. Now again, the second FBD that we will be making will be the FBD2, that is block 2 kg just after, not just after collision, actually it should be after collision. So for that, here we have the inclined plane. The initial position of the block of mass 2 kg after collision will be this position, and the final position will be the position from where it actually started, that is the position where its velocity was 10 meters per second. Now when it reaches here, in the second case its velocity has been given as 1 meters per second, and the velocity in this case here will be v2, that is the velocity just after collision. So again, if we apply the work energy theorem, then delta KE will again be equal to work done by friction plus the work done by the gravitational force. Now delta KE in this case will be half into small m into final velocity square minus initial velocity square, which should be given as again minus 6 into mu into m into g into cos theta plus m into g into hy. Now here we have taken the gravitational work done, that is the work done by the gravitational force, as positive because both the gravitational force is also in the downward direction and the displacement s is also in downward direction. So since both are in the same direction, the gravitational potential energy will be positive. The gravitational work done will be positive, not the potential energy. So and the work done by friction is always going to be negative because friction always acts, in the opposite direction of motion of the object. Now if we again solve this equation, v2 comes out to be 5 meters per second. So and this is in the downward direction. So v2 is the velocity of the block of mass 2 kg just after collision. The velocity just before collision was 8 meters per second. After it collided with the block of mass m, its velocity became 5 meters per second. Now again, we will draw a third FBD, that is FBD 3, and that will be for the block capital M after collision. So what will happen is again the same work energy theorem, delta Ke will be equal to work done by the frictional force plus work done by gravity. Now delta Ke for the block of mass capital M will be equal to half into capital M into final velocity square minus initial velocity square, that is the v3 square. The work done due to friction will be equal to minus 0.5 into mu mg cos theta. Why 0.5? Because in the question we are given that after collision this block travels a distance of 0.5 meters. Okay, so after collision it travels the distance of 0.5 meters. Here the vertical distance we will be considering as h2, and h2 will be equal to 0.5 sine theta, because if this angle is theta, then this angle will also be equal to theta. So from here we will be calculating the value of h2, as sine theta is given in the question. So putting the value of sine theta in this equation, we will be getting h2 equal to 0.025 meters. Now let's get back to the equation of the work energy theorem. The work done due to gravity will be equal to m into g into h2 with a negative sign because the block is moving upwards and the gravity is in the downwards direction. Now again, if we solve this equation, then capital M will be removed from this equation because it is in both sides. So if we cancel capital M from both sides, and simplify the equation. There will be only one variable left in the equation. So solving it, we get V3 equal to 1.72 meters per second. So we have all the three velocities that are needed to find out the coefficient of restitution. We have the velocity of this block 2 after collision. We have the velocity of block of mass 2 kg just before collision, and we have the velocity of the block of mass capital M just after collision. Now, if we recall the formula of coefficient of restitution, then coefficient of restitution is equal to mod of final relative velocity upon initial relative velocity. This is the velocity after collision, and this is the relative velocity before collision. Now, if we put it in the formula, then as both the blocks are moving in the opposite direction before collision, then here we will here we will be having V2 plus V3, and just before collision one of the blocks was at rest, the other one was moving, that is the block of mass 2 kg. So here we will be having V1. Now if we put it in the equation, if we put the all the three values in the equation, then we have the value for coefficient of restitution to be 0.84. So this is what we were asked. The coefficient of restitution is 0.84. Here we have one of the answers. The another question that was asked was the mass of this block. So how we will be finding the mass of the block? To find out, you have to apply the concept of momentum conservation. Why the theorem of momentum conservation? Because here we are having an elastic collision, and in elastic collision, I mean under elastic collision, it does not really matter whether we have a rough surface or a smooth surface. If it is an elastic collision, then momentum conservation will be applied. Momentum conservation will be applicable in that situation. Does not matter whether we are having a rough surface or we are having a smooth surface. So here we can apply the momentum conservation. What is the principle of momentum conservation? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. That is the total momentum of the system before collision is equal to the total momentum after collision. Now we can apply the conservation momentum equation in our given question as 2 into V1 plus capital M into 0 will be equal to minus of 2 into V2. Why minus 2 into V2? This is because the velocity of the block of mass 2 kg just after collision is in the downward direction, and in the downward direction we consider the velocity to be negative, plus capital M into V3, that is the block of mass capital M, and V3, that is the velocity of this mass just after collision. Now if we put the values, that is 2 into 8 equal to minus 2 into 5 plus capital M into 1.772. So if we solve this equation, then capital M will be equal to 2 into 8 plus 5 divided by 1.72, which comes out to be 26 divided by 1.72, which is equal to 15.12 kgs. So we have the mass of the block to be 15.12 kgs. This is the mass of the block that we were asked. So let's again revisit the question. Here we were given that this block of mass 2 kg, it moves in the upward direction with a velocity of 10 meters per second. It strikes with this mass. This mass moves upward with a velocity v3. Just before striking, the velocity of this mass of 2 kg was v1 in the upward direction, and while coming back, its velocity was v2. So we had to find v1, v2, v3 by applying conservation of energy, or say the work energy theorem. Then after solving the equations, we get the values of v1, v2 and v3, and after that we just uh, apply the formula of coefficient of restitution, that is this formula. This is a very important formula in any question of collisions. This is a very basic and the most important formula. So applying this formula, we just put the values of v1, v3 and v2, and we get the coefficient of restitution to be 0.84. And after that, applying the momentum conservation. Remember, we are applying momentum conservation despite the presence of the frictional force. That is, the frictional force causes some loss of energy. Despite of that, we are applying momentum conservation. Why? Because we have an elastic collision. That is, after the collision, both the bodies separate apart. It is not an inelastic collision. So therefore, we applied the momentum conservation in the given situation, solved the equation, and after solving, our answer came out to be 15.12 kg. So this is the mass of the block, and that's all for the solution of this question, which came in JEE Advanced 1999. It was a very good question where you required a decent knowledge of, you know, uh, free body diagram. You required a knowledge of, components of forces. Require the knowledge of momentum conservation and collisions. So I hope you understood the question. I hope you understood the solution. I hope you enjoyed the lecture. That's all for today. Till then, bye bye, take care, and Jai Hind.